Hi, I'm going to be talking about running containers in a microservice environment and mostly try to ignore the arguments around whether we should use containers, should not, whether microservices should be used. At Clever, which is where I work, we've made our decisions, and I think every company makes their own decisions. What I am going to focus on is kind of like the mushy side of building deployment pipelines, like how engineers in an organization think and how they work. What does that mean for the deployment pipelines you build on managed services or internally? So to start with, I want to give some context of what Clever does. Clever is an education technology company. We power data sync and single sign-on for most schools in the US. And I have been working at the company pretty much from the beginning on some form of infrastructure or another. Right now, there's about 5 people in the infrastructure team. And my role particularly at this point is, as a technical product manager of infrastructure, my users are engineers at Clever. And since we do a lot of stuff in open source, there are engineers who are deploying code everywhere in the world. And I really like that because I am attempting to make their lives and their work easier, which means they can do better for students and teachers in the case of Clever. So overall, what I'm going to talk about is first give a sense of what does deployment mean at Clever today, what are the various tools and services we use, how we put them all together. And then to highlight some of the strange decisions that some people think are strange that we went through, I'm going to go through some stories of why we made those decisions. As I think everybody who's built any infrastructure knows that these discussions are not always happy. So I'm going to hopefully expose some of the untidy work that went over the last 2-3 years to get us to a place which we are very happy with today. And then I'm going to talk about control planes. This is what we call every tool or service at Clever that sits between engineers and the underlying infrastructure, a lot of it AWS infrastructure, but also other services. We try to make a control plane, which is kind of like a cockpit, so that engineers are always using a coherent set of tools. And in the end, based on the principles that we've figured out for these control planes, I want to give kind of like some perspective of work that we are doing today, which hopefully will allow you to critique our principles, given I'm sure you have your own opinions how we should be doing the new work. So to give a perspective of what kinds of deployments we run currently, there's about 50% of US schools use Clever today. Millions of students use it in classrooms every day. So from one perspective, every deployment is a way for one math class or an English class to totally go crazy. Because you can imagine if there are 10-year-olds and they can't log in, now the teacher has lost the classroom. So it's very important for us to get this right. But this is the last week in deployments that I put some metrics about. We launched more than 100,000 containers. There were 100 different applications launched. So I don't think I need to say that we've bought into microservices explicitly or implicitly. I think this qualifies. These 38 engineers, which includes managers, made over 500 deployments over the last week. And I'm sure that number has become more since I've not been looking today, in over 20 environments. Now, what environments mean at Clever is something slightly different and unique to us, so I'm going to kind of dig into the stories of what that means today. One of those environments is production, of course. On average, these deployments took 6 minutes from when tests were finished in master. So somebody wrote some code, merged it to master, it went through an automated test, and as soon as that was done, within 6 minutes, that piece of code was being used by students or teachers. Most importantly, engineers at Clever love the tooling. At our company offsite, there are usually chants of our tool name that is used for deployments. And one of the reasons for this is that they feel that they can move really fast using these tools. So these tools wrap over, like I said, a bunch of different services. We use GitHub to store all of our source code. A lot of it is public. A lot of it is also private. Early this year, we moved to Circle CI, which is kind of like a build and test, like a CI service. We used to run this ourselves, and we've decided that we understand it well enough that we can now outsource this complexity to another company. We also store every commit's Docker container image on both ECR and Docker Hub. We do this because we've seen resiliency issues, and a Docker container not being available is really bad for a company that only deploys Docker containers. On top of this, to take that code, like I said, when it's merged to master and a container is created, we've built some of our own tooling. So I want to introduce some characters that at Clever we are very familiar with. That is Arc. It has the little Golang gopher because it's written in Go. Catapult is kind of like the REST API that Arc, which is a CLI that talks to. And Dapple, which is our cute little pony, is our Slack interaction interface. Dapple is responsible for talking to engineers on Slack, alerting them when they need to pay attention, and we are also using it to build more automation into our deployment pipeline. So these tools take these artifacts that are stored in ECR or Docker Hub and kind of deploy them on a range of AWS services. For most of our applications, we are using CloudFormation to manage change sets. We deploy everything on ECS for orchestration. This currently includes both batch jobs and services. And all services are fronted by ELBs. We are in the stage right now where we use both ELBs and ALBs, and we also use some custom-built HA proxy load balancers that features for which are not yet available. But like I said, my focus is on what engineers do as users. So as users, engineers at Clever have the following features in production. They can roll over to a new version. What this means is they can take a new application that they've built, deploy it. It will roll out the containers one by one, do health checks. If everything is OK, it'll completely remove the old version. Now, anybody who's used CloudFormation, this is what CloudFormation does for us automatically. So there was no big work here. We also provide rollbacks. What this means is that at any point in time, a certain application can be taken back in time. And this, you can sell, mostly people will roll back application, which means the code, the configuration, and you can choose if you want to do that with secrets, because sometimes secrets only go forward. We also built on top of ECS and CloudFormation the support for canaries. Now, canaries have been really important for us because we can do changes that really change kind of like the performance behavior of our applications. So if we added a new complex piece of code, we want to make sure that it can handle the traffic. A canary, an engineer can choose to only give 1% of traffic to the new version of their application, look at the statistics, look at the graphs. If that looks OK, they can roll forward completely. We also support feature flags, and what that means is something very similar to canaries, which is you take a small subset of your users. But in this case, you select who the user is. In our case, we will release a new feature only to a specific school. Because some schools work very closely with us. They are more open to having things that might fail than large public school districts who have huge impact if something goes wrong. So this is for production. But anybody who's been an engineer knows that you spend most of your time in development. What features does our team support in development? We actually support all of those things, and they're all heavily used. The best part of this is, since deployments happen more in development than in production, as the infrastructure team, we get lots of testing of our tools before anything goes into production. So we love that. Also, engineers are our team's focus. They spend most of their time in development, so why should the development environments be less than what they get in production? Of course, it has the side effect that they find out about their mistakes very early, rather than when it hits schools. We also provide, rather than feature flags, which you can use, but there's only 38 engineers. Feature flagging doesn't really work that well. We allow this idea, again, of on-demand environments. What that means is that any engineer can create their own environment, which is kind of like a copy of Clover, of all services. But to really explain what on-demand environments is and why it has been very important for us as a culture, I want to go through some stories. And so the story I'm going to start with is how we got to on-demand environments and the kind of rough path that we took there. The context for that is, looking back, since the very beginning, about 10% of our team has been working on tools focused on engineering. And now we think of this as a very valuable thing that we do. So currently, we have 4 to 5 engineers who work on developer tools out of 40 to 45 total number of engineers at Clover. And this team is responsible for building products. We don't have an SRI team. We don't have an operations team. We don't have a build and release team. Every team does their operations by themselves. But if they do that wrong, some of that blame is mine, because I haven't built the perfect tools for them to find out their mistakes before they actually hurt our users. So I'm going to start this story in a place where I think most of us have been, which is these large discussions, which usually are called bikeshedding, which is you're talking about a small technical detail, and we keep going on and on about it. There are lots of opinions, but nobody really understands why this is so important. One of these things for us was, should we run containers locally on developer laptops or not? And it started between me and an engineer who shall remain unnamed, but that's him. And this was, I was very angry because a new engineer joined Clover, and they couldn't figure out how to, it took them 4 days to start working on a new application, on an existing application at Clover, but which was new to them. And then I found out that this person was responsible, and this was what I heard. If my code runs in production, I shouldn't have to make changes for it to run locally on somebody else's laptop. And in some ways, I agreed that he was right. He was really focused on his users. And we started debating how much time should be spent in one place versus another. Like, developers are important, and other people's velocity is important. Soon, it became very messy. There were about 30 people in Clever at that time. I think about 80% of the company got involved, and this happened within an hour. I don't know if you've ever been in a company like this. I love it because that means everybody cares. And everybody had different opinions. Everybody thought that different things were important, and we realized we weren't really making any progress. So we did this asynchronously, where everybody wrote what they really thought about this discussion. And this common list of things, which I'm sure everybody's run into, who's ever used microservices, you've definitely run into this. But even otherwise, we were basically hurting as we were growing around configuration. What this really ends up being, like, something runs in production, it's been configured over time. Now when a new person starts running there on their laptop, they don't know this one variable that is the magic number that you need. And you can't just copy it from production because you don't want to use a production config value. So where is this? Now you have to hunt down that person who first ran this, or somebody who's been able to run this recently. Dependencies. At this point, we were 15 to 20 engineers, and we already had about 100 services. But I had only ever touched 10 of them. So to run those 10, I needed some other services. How do I know how to run them? Where are they? This is, if you read any of those articles about why microservices are the worst, this is the complaint, and we were in that world. And the last one was, even if you managed to get everything running, what if one of those dependencies fails? In a specific use case, where are the logs? Where are the metrics for it? It's all on my laptop somewhere. How long do I search for it? And as a new engineer, this is what I see very often. people are very afraid to ask questions. They think that they're just dumb. They're not able to find it. But that's not true. So, that list was not good enough because I knew that every company faced those. I had read lots of blog posts about it. But there was something special that everybody reacted so emotionally in our group about this one simple conversation. So there must be something that was unique to us. And I think I want to reiterate, this is the reason why I think that this conversation is really interesting, at least to me, is that every company feels the same pains, but the reasons, the emotional reasons are different. And technical design can really help supercharge those emotional feelings. And you can also get to do things faster because everybody will help you. So for us, it was things like this. It was some base values that people had adopted as they worked on our products. Infrastructure was a team, which I was defining at that time, as a team who does not do operations. We did not want to be the people on call all the time. We wanted other teams to be on call. And they were like, well, if you do that, make a better product. Have an opinionated product. Don't have me do extra work just because your product doesn't work. That's fair. And that was a cultural thing that maybe in other companies won't work, but at Clever, that's true. The other thing was our whole business is about automating dumb tasks that we don't think humans should be doing. We think teachers should be teaching in the classroom, not setting up accounts. So why not expect that from our tooling? And the last one was, and this is where it all really started, is that as an engineer at Clever, you really talk to your users and you solve their problems. At that time, your number one priority is to make sure that that classroom gets going or that school is able to get the app that they want to get configured working. It's not to figure out how infrastructure works at Clever. And what I realized with that is that if we want to keep those values, we have to figure out some other solution rather than just accept configuration and dependencies will always be an issue. So that's when we came up with Arc. And the basic philosophy behind Arc was something like this. We should make a tool for development, for non-production deployments, that is so good that one day we will just start deploying to production with it. Mostly people do things in development because they're testing if it's good enough for production. What we wanted to do was make something so good for production that people just used, so good for development that people just used it for production also. And this is why most of those features that I talked about, rollovers, canaries, they actually are used for the internal infrastructure system to roll out. And then we know when we can roll out our entire infrastructure on that, we can probably roll out one application also. And for this, it was required that we have on-demand environments. What this means, because we were making the explicit decision that you don't run the dependencies on your laptop. Your laptop is throwaway. And what this means is that at Clever, an engineer, when they start some code locally, they use Arc. It just uses your makefile or whatever build system you use to just spin up the code. But all the configuration, all the dependency finding, all the service discovery, which is to find all the services that you should rely on, finding databases with mock data, all happens on ECS in the same way that these applications are running in production. What our infrastructure products do is basically dynamically scale these things based on how engineers need them, which is a really useful feature because it also helps in production. So today I checked, we have about 25 different environments running. Most of them are probably partial copies of Clever. Some of them probably have all applications that run in production Clever in them. And people might be running their branches, some custom configurations, some new features, some performance improvements. It doesn't matter. This also had some other very interesting things happen, which is the environments were used to share them with product teams. So now, if I'm working on a new UI feature that requires 5 different services to present new data, I can just give a link to my work to the product manager, and they can check whenever they want, and they can use it as if it's the real product. And that came mostly for free. However, as we started using Arc more and more, adding new applications became really easy. So the number of services that we had exploded even more, which we think is a good thing, which means that it was working. But another discussion came out, which was, what are applications? Is Clever an application? Are these microservices, each one of them, an application? We said, oh, yeah, that's simple. Like, we run lots of microservices. You can call each of those things an application. But is it the code? Is it that GitHub repo? Is it the Docker container? Is the Docker container and the configuration? And this was hurting us in real ways because we couldn't release new kinds of behaviors that engineers needed to work with. For example, we want to introduce asynchronous workflows, which means things that run when a job is required to be done and then turn off. How do we explain that to engineers so that new engineers can quickly decide whether they want to go one way or another? But to give you a sense of all of this, I want to kind of like go through what Arc means. So I've set up this problem of applications, but I want to kind of like go through a strange route of actually showing you our command line utility as we use at Clever today. So I'm going to try to do that. Let's see how much of that works. Let's see. It does not. Okay. Perfect. Great. So, this is my preferred way of working on the command line on Linux. So this is the tool Arc that we use. It has lots of different things. It doesn't matter. It has lots of help. One of the things that you can easily do is start a new application. So this is Arc init. It gives you lots of details about what kind of things you can do. In this case, you don't need to go through all of this. All it's trying to say is that we have lots of templates, so if you want to start a Go service, just start from the template. Don't try to invent it again. One of the things that I want to do is I want to start one, so let's say Arc init. I want to give a description, testing in real time. I want to make it public so that you all can see it, that it actually worked later. I created a template today and called it template demo, which basically is a hello world application. And then we are going to call it AWS Summit Live Test. Let's see what happens. So again, very basic CLI interaction. So luckily, all network requests went through, which is kind of amazing. So what happened here is that this connected to our internal infrastructure with my authentication tokens on my laptop. It identified me as Mohit, and I have some permissions in the org. It created for me a GitHub repo, which is public, so you could go look at it. It created a Docker Hub repo, which is also public, because of course, if the code is public, maybe you should be able to run it too. It started a build and release. So you can't really have an application or deploy it at Clever unless you build it. And it creates some private default configuration for Clever so that we can run it inside Clever also. Now you don't need these configurations properties to run it, but we would need them if we need to run it inside our infrastructure. You could run this on ECS outside also. More importantly, again, the reason why I wanted to do this demo at this point is how the definition of application is strange, because any one of those things could be part of all of the application. You could take one of them and don't need the other stuff, and you could run it. But in this case, it also created a bunch of files for me locally. So in this case, what it did is it created the configuration files required. It gave me a make file, because some people like that. I do too. It also created an index.html file with hello world in it. which is basically part of the template. It did some template filling to make sure. And it tells me at the end, hey, now you can start working on this code. So we were able to do this, but we also wanted to make sure that we have a clear definition of what this template means. What did you just create? And that was becoming harder and harder. One of the other things that I wanted to just kind of like go through to give a sense of what deployment flows at Clever look like is, let's say I just want to start a new an environment. So I created an environment just while I was outside. I called it CSoup. And let's say we start Events API, which is one of the services that I run internally sometimes. Again, Arc is taking my credentials, trying to look at this environment called CSoup, which is conceptually isolated. And what it did was it said, hey, you don't know what this thing depends on, but I know that it runs some asynchronous jobs on Gearman. I'm going to give you a whole Gearman server for you so that other people can't mess with your work. I'm going to give you an administrator service, some other permission service. These have empty fake data. So it's using some fake data databases in the background. And it said, you know what? You already created some of these in the past. I'm going to just use them. And I'm going to move on and look at the ones that don't exist, start them. And it usually takes about 2 to 5 minutes, and we would have these services running. So I kind of want to stop there. It doesn't really, it'll basically spit out the version number and a URL, which is where you can share it with other people. In this case, it'll be private and nobody else can hit it, but you could also do the same thing to launch a public service. Now I want to end here because a public application and a private application, is that a property of an application? We don't know. Okay. So all of those features existed before we ran into this issue of applications, and we had some ways to define it. And currently at Clever, when that new application was created, what we think of an application is this. From the infrastructure team's perspective, this is what an application is. Now, what is it saying here? This is a service, which means that it must have that little expose block, which means that it's exposing port 80, which means that it'll put an ELB in front of it, or an ALB now, I guess. And there's some health check defined. There's some required configuration, so that we can make sure you will never start this app if those properties are not available for your environment. And those configuration is parameterized so that you can create new environments willy-nilly and it'll find the right thing. Dependencies. Now that was important for us because I don't know how many, but we've run etcd clusters. We've run Zookeeper. We've run many other distributed computing systems just to do service discovery, the main point of which is to find your dependencies. After doing this, you know that every engineer has set up the dependencies correctly because as they write the code, they want to find the dependency to make their code work. In that moment, they'll add the dependency, they run the code locally, it starts the dependency in the cloud, makes sure that it works, and that's how they launch in production. So if I take somebody else's code and start it, I know that the dependencies will be correct. So these were some interesting side effects of clearly defining in a YAML format our own version of what an application is. And I think this is something that is very important. We tried to take the CloudFormation or the ECS way of defining an application. Kubernetes has their own. But really, I think this is the part where an organization needs to define their own. So this is one of those control planes that I talked about, just this file. It also has some other side effects. Now you can take the same Docker container and make a new, so one of the things that I missed in this one is it also defines CPU and the maximum memory required. So what some teams have done is they're like, oh, this service exists, but I need it at a higher throughput level. So they will just make a new application, that file, name it something else. It points to the same Docker container, and it just uses a lot more resources. So this way, I could depend, and the same thing works for dependencies. I could depend on a version of an application that is high throughput or high resource, and somebody else could not. And this worked really, really well for us, on the surface, to provide this interesting user experience to our engineers who really like the fact that they never have to think about the stuff that they don't know. This was me doing this before. But also, during crisis scenarios where something breaks, we can now generate these graphs on demand. So let's say this events API failed. There were some errors with it. Wait, it could be events API. It could be something underneath. How many things do I need to check? Well, you could use a graph and try to figure out what are the different things that could have broken. This is generating using GraphViz, which is like an open source. Like you just give it a graph and it'll draw it out in different ways. What it also means is that on clients, when you're writing a new app and you need to discover your dependencies, our clients just, if you say new from discovery, which is our internal library that does service discovery, is actually nothing complex. Because when we start the application, we just put where their dependencies are in the configuration of the application. Now, at our scale, this works great. Because what if a dependency changes in real time? Well, we either put it behind the same load balancer, or we will restart the container gracefully. So I can understand that many larger companies, and I don't think there are many, might need a distributed system for solving this particular problem. We are able to run this with just configuration changes, and that makes everything much easier to debug. So I'm going to kind of pause there with kind of telling stories about Clever and actually talk about how are we designing this tool called Arc or other tools. The first thing that we've learned over time is to highlight our quirks. The humor in the team and the little jokes that everybody plays, all of our tools have them embedded. One of the largest code source files at Clever is this shared emoji file, which connects an emoji that can show up in Slack, Terminal, a website, and associated with an emotion. So Arc and Dapple and other tools that I talked about will express their emotions because they have this giant list of what our teams think a certain emotion can be expressed as. That is an actual error message, which if you try to roll back and change resources in production, we don't allow paradoxes in our world. The other thing that we've learned is to outsource complexity wherever possible. And this is how we find time to do all these UX-related things, to really think about, okay, how do we define application? What should that file look like? What should go in there and not? How many things are we doing automatically? And therefore, that is why we love things like Amazon and Circle CI, because once we figured out what we want to get done from a build system, somebody else can do it, and we can wrap it up to what we need out of it. So most Amazon managed services offer too much power. And at the infrastructure team, I think our goal is to wrap it up into very, very thin layers so that I can deliver the value within a month. So some of the new projects that we are doing started from zero and are actually in production within a month. And if you really look at it from inside Clever, like what Arc exposes, it'll be a shadow of the big announcements of how Amazon talks about the power. But we've selected the parts that work for us. And then we use them. We try to understand what do engineers at Clever really want from the system. The other thing that happens is that we slowly understand the Amazon service better. Because in the beginning, we don't really know all the different parts of it. And what we call it is finding our defaults. So for example, one of the big projects that we are doing is moving to AWS Batch, or actually we are in the process of moving to ALBs, and we provide the same functionality on ALBs that we provided on ELBs. We do not take advantage of any of the new features, but every day, we are understanding how ALBs work for ourselves much better, which reading documentation doesn't offer at our scale. The other thing that is happening is that now that engineers know that there are ALBs in the background, they don't have to really think about it, but the ones who think about it argue for the new features. They want to do something. And so I know exactly what to expose and not the whole ALB, which is designed for everybody in the world. So again, I started with the ALBs. I want to give some other examples. For Arc, we are moving from AWS CloudFormation, which is what we use for deploying all these applications. So to give you some context, if you're interested, technically I can talk about this a lot later, but when I did that Arc command, it basically created a bunch of CloudFormation change sets and applied them. And that works really great, but we want to add custom delay blue-green deployments. What that means is that I want to start a deployment today, and I want to roll over to the new version in the next 6 days based on which users are okay with the role going to them, with the rollover going to them, a new version going to them. And this is not really supported in CloudFormation very well, but after running ECS for the last year and a half, we understand ECS very, very well. So now we can thicken those lines of our thin layer because we are very confident we understand the underlying service. So we are basically, what we are doing right now is to take parts of what we do with CloudFormation today and interact directly with ECS. We are also, like I mentioned, early this year, we started on this tool Dapple, which the user interface for which is Slack. And Dapple did not start off as a Slack bot. It started off as an automated deployment pipeline. What it does is things like, hey, this service is very small. It doesn't impact many users. You've made a very small change. I'm just going to deploy it in production. Or you've already run this as a canary. All the stats look fine. Let me just roll forward. But what happened at that point is that engineers felt a little antsy, at Clever at least, that they might be having impact and they might leave their desk. So what Dapple eventually became is this like quick fire conversational thing, where now what it does is when a build is complete, it'll just tell you, hey, build is complete. Do you want to deploy or not? Many engineers just use it as a notification that a build is complete, so that works too. We are building a new functionality into it right now, which is when you run a canary, after the canary is done and it waits a few minutes, Dapple will tell you if the stats look okay and give you a graph. So you can make the decision right there and then if you want to just go over. So there's lots of this awesome stuff, but for me, one of the awesome ones is I can now do deployments from my car. The last project that I want to talk about is supporting workflows, which means that to run large chains of long deployments, doing big data transformation pipelines, and taking them off of just ECS into AWS Batch, which we think will save us a lot of money, is the primary reason for this project. But again, our focus is on trying to see what engineers at Clever really want, what are the ways we use these things. Yep.
How are you utilizing microservices in this? I mean, you talked a lot about your process, but I still don't see, how you linking it very much to ECS. Where does that come into play? How is that making your environment different from the past? What contributions is ECS doing?
Well, we run everything on ECS, so it would be very hard for me to tell you like how it will help you. I think you should talk to people at Amazon. I don't work there. For us, it really helps us.
This workshop was about microservices, right?
Yes.
Okay, so, I mean, you're not saying a lot in terms of how, in the concrete world, how you're using microservices, what they're doing for you all. I understand you said you run everything on it, but what are you doing? Let us know how microservices are improving your product from the past, how they give you an advantage versus other companies. I mean, that's what I'm at, that's what I came here for. Not to understand, like, your development processing without divorce from microservices?
So I should answer that question. Okay, I will answer parts of that question, and if you want to talk with me more about some of these things that you came here to do, which
I mean, that's what the title of this thing was, right?
So we're going to have questions after the talk. Let's finish the
yeah,
talk
I'm
first.
sorry, like I don't know what you read, but I'm willing to answer your question. I feel a little strange answering a question about what the title of the talk was. So anyways, so basically what we want to do is to move workloads onto AWS batch, which take a lot of time. The primary reason for us to do this is we spend a lot of time on running large jobs. And schools are of various different sizes. So we have to kind of allocate resources for the biggest ones. Batch allows us to use Spot, which we are very excited about, which we don't use today. But one of the new things that we are trying here is to use, to expose this idea of control planes to the outside Clever. All of the development on batch is happening in, I wouldn't say open source, but it's a public repo. So I've been building this. It really focuses on putting a very thin layer. So it took us about 2 months to go from, we should build a new tool that thinks about how asynchronous services work as different from HTTP services. And they need engineers want different kinds of answers from it. They want to cancel a specific thing. They want to not know the container ID. They want to know what job started that has now eventually gotten to this container. They care less about aggregation of logs, but want to see all the logs because it's in context of a specific job running. So some of these ideas are interesting, and we've been working on it with starting right now only linear workflows. So this is an idea. The reason why I want to say this is we are focusing on very, very small feature sets. So you can go from A to B to C linearly, and that's it. But it runs on batch. We have a thin wrapper that allows you to do the complex interactions that you would want to do. We are using the states language, which is used for, I don't know how many people have used step functions, but basically the idea here is that can we take something like step functions and run AWS batch by using the same language? Because people already like that. So again, that's the idea. And that's it for me. Any questions, I'll be here. That's it. I hope this was helpful.